The muscular system. The muscular system is made up of approximately 650 muscle, depending on the source. The stapedius is the smallest muscle in the body, which makes sense because it's attached to the stapes, the smallest bone in the body. The gluteus maximus is the largest muscle, and not surprisingly, it's also connected to the largest bone, the femur. Muscles are categorized under the three primary types: cardiac, smooth, and skeletal of the heart to make it contract. Smooth muscle is located throughout the body in regions such as the wall of the intestine, uterus, blood vessels, and inner eye, and also stomach. Skeletal muscle is the contractile soft tissue, that drives and controls the movements. Because this course is primarily about movement, that information in this unit will be about the action of skeletal muscle. Therefore, for the reminder, if muscle, it's related to specifically skeletal muscle. Muscle attachment. Virtually every muscle in the body has two attachment points that correspond to two different bones. The location of the attachment points are described as origin and insertion. When a person is standing in the anatomical position, the origin is the muscle attachment close to the head, and insertion is the attachment close to the feet. Each origin and insertion end of muscle belly connect to its respective bone throughout a tendon. Tendon structure and function. The primary function of a tendon is to transfer force between activated muscle and the bone where it is inserted. The structure of tendon is formed from dense connective tissue formed by an type 1 collagen fibers that provide strength. Tendons are similar to ligaments and joint capsule because they all have a limited blood supply and low metabolism. Nevertheless, the metabolism within a tendon can increase when it's physically loaded during movement and resistance training. That is one of the reasons why doctors now recommend exercise sooner rather than later after an injury. Skeletal muscle structure and function. For muscles to jump into action, it must be activated by the nervous system, as we'll cover after that. For now, what's important to understand is the effect that muscle activation has on a joint. A joint can either move or remain static depending on how much force the muscle produces. We will start by covering the functional unit that allow muscle to contract, and then discuss the muscle and joint interaction. Skeletal muscle is made up of bundle of muscle fibers. Each bundle is a fascicle and is covered by a layer of connective tissue called perimysium. Within the vesicle is a collection of muscle fiber, and each muscle fiber is made up of smaller myofibrils. The myofibril contain sarcomeres, the functional unit that can make the muscle fiber shorten. Sarcomeres are lined up in series with the myofibril in the form of rod-like structure. In other words, if the myofibril were a yardstick, the sarcomere would be the inch markers. Each sarcomere can shorten only in a minuscule distance. However, the combined effect of all sarcomeres shortening at the same time causes the entire muscle to significantly shorten. The sarcomere shortening due to sliding of myosin and actin past one another. Importantly, this process cannot occur in reverse order. In other words, when a muscle is activated, it can only shorten, or more specifically, attempt to shorten, as we'll discuss later. Muscle action. When a muscle activated is only capable of shortening, but there are times when a muscle could lengthen or remain in a static position. Even though the muscle fibers are attempting to shorten, it is common for people to refer to a muscle produced as being contraction. However, the word contraction can easily create confusion because it's referred to shortening. Therefore, it's more appropriate to think of muscle possible function in terms of actions, not contraction. In other words, a muscle can perform three possible actions: shorten, lengthen, or remain static. Let's cover the term. Concentric action, one activated the muscle shortens. Eccentric action, one activated muscle lengthens. Isometric action, one activated muscle remain in a static position. Whatever muscle perform a concentric, eccentric, or isometric action depends on the relationship between the pulling force it produces and the resistance force it's trying to overcome. A concentric action occurs when the pulling force a muscle generates is greater than the force applied by resistance in the opposite direction. This causes the muscle to shorten. An eccentric action occurs when the pulling force is less than the resistance force. An isometric action occurs when a muscle pulling force equals the opposite force produced by any type of resistance. Remember, even if a muscle action is either concentric or isometric, the muscle fibers are attempting to shorten. Therefore, the elbow flexor will lengthen even though the brain is attempting to pull the forearm up. Now let's talk about the role of muscles. Most movements are derived by a collection of muscles, and each muscle is capable of playing a different role. A muscle can function as agonist, antagonist, or synergistic, depending on movement. Let's discuss what each of those terms mean. The agonist is the muscle or muscle group most directly involved in producing a movement. For example, the biceps brachii is the agonist for elbow flexion, and the tibialis anterior is the agonist for dorsiflexion of the ankle. Antagonist is one or more muscles that have the opposite action of a specific agonist, because the triceps extend the elbow joint and the biceps brachii flex the elbow joint. The triceps is an antagonist to the biceps brachii and to flexion. Synergists are muscles that work together during movements. Because most movements require a contribution for many different muscles, synergistic actions are very common. For example, the biceps brachii and brachialis muscle act as a synergist during elbow flexion. Imagine curling a dumbbell with your right arm. There will be synergistic action of the muscle that cross the wrist joint to hold it in neutral position during the movement. Furthermore, muscle in the shoulder joint will contract to neutralize any movement at the shoulder. Therefore, even a motion as seemingly simple as a biceps curl can require the synergistic contraction of many muscle groups. Free couples. Another example of muscle synergy is a muscular free couple. A force couple occurs when two or more muscles concurrently produce force in different linear directions to produce one movement. To make a right turn on a bicycle, the right arm must pull inward as the left arm must push outward. The force each arm produces is in different directions. However, it results in one movement. A force couple is required during deltoid and supraspinatus actions at the glenohumeral joints. While lifting the arm out of the side, when the deltoid muscle shortens, it pulls upwards on the head of the humerus. This action would normally cause the head of the humerus to compress up into the scapula, if it were not for the simultaneous inward pull from the supraspinatus. In other words, the combined action that produces force couple can allow joint to move through a greater range of motion. The force couple between the deltoid and supraspinatus is a prime example because the coupling effect avoids impingement within the subacromial space. Now let's talk about the skeletal muscle groups. We have a lot of muscle group. Here's the arm, there is the biceps and the the brachialis, triceps. Here's the muscle of the chest, pectoralis major and trapezius muscle, some serratus, latissimus dorsi, should know the difference between latissimus dorsi and serratus here. Also the muscle of the thigh, starting from iliacus, pectoneus, psoas, adductors, gracilis, sartorius, vastus medialis, lateralis, rectus femoris. Here's the thigh from the side to show iliotibial band or iliotibial tract. Also seeing the gluteus maximus, which lie on the gluteus medius and minimus. Also biceps femoris and the vastus and the semimembranous semitendinosus. Here is the muscle of the abdomen, serratus, latissimus also, plus the external oblique, internal oblique, rectus abdominis. Here the muscle of the leg from the interior, you can say the peroneus longus, extensor digitorum longus, tibialis anterior. From posterior you can see the gastrocnemius, the coelois, the soleus, also the tibialis posterior. Okay, that's it. Thank you. Now we will talk about the fascia. A human body consists primarily of fluids. About 55 to 75% of it is water. Depending on the person's age, gender, and body composition, have you ever wondered why all the fluid doesn't pull down into your feet and lower legs? There is soft tissue net throughout the body from head to toe that holds all the fluids where they should be. This net also functional to connect simultaneously unrelated parts of the body together, such as the foot to the hip or wrist to the neck. It's common for many anatomy books and physical therapy programs to neglect the clinical role of this soft tissue plays during movement. Nevertheless, it's crucial to understand the movement at one joint can have a significant effect on other areas of the body. Therefore, in this section, you will learn the structure and function of the fascia, the body's continuous net that influence movement and posture. Fascia structure and function. Your body begins as an ovum, single cell that's part of the female reproductive system. This cell quickly begins to divide into more cells, and by day 14 of development, a support structure has been developed that holds the collection of cells together. This structure is made up of fascia, a form of connective tissue that acts like guide wires on a suspension bridge. Once the human body is fully formed, this original net of fascia has developed to function like girdle and guide wire that creates interconnectedness and structures throughout the body. Fascia is a tough tissue consisting primarily of collagen similar to ligaments and tendon. If you have ever suffered from plantar fasciitis, which is an irritation of the connective tissue of the bottom of the feet, you know that fascia can become stiff and painful. This area of stiff connective tissue on the bottom of each foot is plantar aponeurosis. Sheaths of fascia sit directly beneath the skin and traverse deep through the body to form an interconnected matrix formed from head to toe. Indeed, movement at any joint can have far-reaching effects throughout the body due to interconnectedness of fascia. The 7 categories of fascial line. Anatomy trains Thomas describes 7 primary lines of fascia within the body. Importantly, each fascial line connects with numerous bone and muscle along its path, and those connections are what form the complex matrix that links the body together during movement and posture. For the sake of simplicity, the following information describes the general path of each line of fascia starting from the most distal point. Okay, first the superficial back line, which is this one. This fascial line runs from the bottom of the toes up to the back of the legs, along the spine over the top of the skull and attached to the forehead. Next, the superficial frontal line. There are 2 parts of the superficial frontal line. The first part runs from the top of the toes up the front of the leg and attached to the front lateral aspect of the pelvis. The second part runs from the anterior medial aspect of the lower pelvis up the medial aspect of the trunk and split at the top of the sternum to warm up and around the lateral aspect of the neck, where both sections merge to form a continuous loop around the back of the skull. Next, the lateral line. The lateral line runs from the mid-lateral aspect of the foot up the lateral aspect of the leg and pelvis, crisscross underneath the rib cage and up the lateral neck where it's attached behind the ear. The spiral line. The spiral line loops around the bottom of each foot like a long scarf and runs up the lateral aspect of the leg. Then it takes two different routes at the hip. One track round across the front of the hip, up and across the abdomen, wraps around the upper rib cage and the opposite side and continue up the back of the skull. The other track crosses over the back of the pelvis and run up the spine until it attaches to the back of the skull. Arm lines. This category of fascia consists of 4 lines. The deep front arm line runs from the tip of the thumb up the lateral arm across the shoulder and attach around the nipple. The superficial arm line runs from the tip of the fingers on the palm side, travels up to the medial elbow, up the medial upper arm, across the medial shoulder, and attach at the medial clavicle, sternum, and directly below the chest. The deep back arm line runs from the outside of the little finger up the forearm to the elbow, up the posterior upper arm, across the posterior shoulder, and attached on the spine of the lower cervical and upper thoracic vertebral area. The superficial back arm line runs from the tips of the fingers on the back of the hand, up the elbow and posterior upper arm, across the top of the shoulder, and attached to the base of the skull, lower cervical and mild thoracic area. Functional line. 3 functional lines make up the functional line. The back functional line runs from the lateral aspect of the knee up the posterior thigh, across the posterior pelvis, over the lower half of the rib cage and scapula, and attached to the upper humerus. There is a front functional line that runs posterior middle femur to the middle pelvis up the medial abdomen and out across the chest to the upper humerus. The ipsilateral functional line runs from the medial knee up the inner thigh at a lateral angle that crosses the lateral pelvis, over the lateral posterior rib cage and attached to the upper humerus. And lastly, the deep frontal line. This fascial line runs from the bottom of the toes, up the lower legs below the tibia and the fibula, behind the knee, up the medial thigh, over the front of the pelvis, up through the rib cage, and continue up the anterior and lateral neck where it's attached to the lateral aspect of the jaw and skull. Final words. The key element to understand about fascia, it's a rule in connecting seemingly unrelated body parts or structure together. Indeed, a problem at one joint can and will often lead to a problem at other parts of the body. This is due to interconnectedness of fascia throughout the body soft tissue structure. And thank you.